So so endurance, we're talking about endurance now, done with the range. So endurance is time by fuel. And if I divide numerator denominator by time, I will get 1 by fuel consumption. So what can I see from here? I can see that if my fuel consumption is more, what happens to my endurance? It will be less. And if fuel consumption is less, my endurance is going to be more. Now what dictates this fuel consumption? That is the fuel used per unit time. So that is connected to per unit time. So anything that is connected to time is controlled by, or is connected to what?
Range.
What?
No, power.
Is connected to power. Anything that is controlled by time can be, or time dependent can be controlled by power. Rate of climb, it depends upon excess power here. We'll see that later. And so anything that is rate driven, it's controlled by power. So because power itself is rate of doing work, right? Now, so I told you before that what is meant by RPM? RPM is revolutions per minute. So every time the engine completes the revolution, say for example, if it completes the cycles, it will take up a bite of fuel. For the next revolution, it again takes another bite of fuel. So if I compare two different engines, one with 1500 RPM and the other with 2500 RPM, the one with 2500 RPM is going to consume more fuel because it is revolving more at a given period of time. Therefore, this is going to have a higher fuel consumption. So two aircrafts with these two engines, with all other factors being the same, which of these is going to have more endurance? The one with 1500 RPM is going to have more endurance because it is having lesser fuel consumption. Make sense? So that is why we say that when you have minimum power, you will get what? Maximum endurance, right? Now think about endurance. Endurance is how long you can stay up in the air, right? Now think about increasing your weight. So what do you think is going to happen to the endurance? What do you think is going to happen to the time that you can stay in the air for a given amount of fuel when you're heavy? So when you're heavy, you need more lift. And to produce more lift, we have to actually have a greater power to actually stay up in the air, right? Now think about this. I have told you this as well before. Usually if I want higher lift, what is one of those methods by which I can acquire more lift? So when weight is higher, your lift required is higher. What is lift equation? Lift equation is CL half rho V square times S. So one of the techniques by which you can actually increase your lift is by increasing your speed, right? So if you look at the power curve, power and speed, the power required curve is like this, right? This is the point where we have minimum power, and the speed corresponding to that is called as VMP, which is a minimum power speed, and the value of power corresponding to that is the minimum power. This is the speed which is going to give us maximum endurance. We have seen this graph before, the power curve. This is where we explain the stability and stuffs for power as well as thrust curve, right? Now what happens when I increase my speed to produce more lift? So increase in speed is actually going to, so we're talking about indicator air speed. So you need more lift, which means I need more indicator air speed, more dynamic pressure is required, right? Because see, I need more lift, therefore I need more dynamic pressure. How can I increase my dynamic pressure? The only parameter which I can control within dynamic pressure is V. I cannot control density. So how will I control V? That's true airspeed control using the throttle. So I have to now increase my true airspeed to increase my indicator airspeed. So when my indicator airspeed increases, what happens to the power? Power required. Power required increases. Right? Now, for that matter, if I decrease the speed also to stay up in the air in the decreased speed, I have to have more power as well. So when you increase the power, so when you increase the speed, power has to be more. Power has to be more means what happens to your endurance? When power increases, the endurance is going to reduce. You are now consuming more fuel, and therefore your endurance is going to crash. Therefore, with increasing weight, your endurance drops, which means if you could stay 2 hours with 2000 kilograms, you can stay only 1 hour 15 minutes with 2500 kilograms. As the weight increases, the amount of time you can stay in the air with the amount of fuel available reduces. Now we think about wind here. Wind. Now yes, you take off, you're flying at say 100 knots, right? And now, say for example, you have enough fuel in your aircraft for 2 hours. This is what is called as the total endurance. Remember, total endurance is the time that you could stay in the air, after which your tanks will be empty. You use your flight fuel, reserves, everything, dry tanks, that time is called as total endurance. Safe endurance is without the reserves. You've studied all those things in your CPP and all stuff, right? Safe endurance is just by using your flight fuel, right? So if I have 2 hours of total endurance, the meaning of that is after 2 hours, I will not have any drop of fuel in my wing. Right? Now you're taking off, you're flying at 100 knots, and imagine you have 100 knots of headwind. What is going to happen to you as far as your range is concerned? When your true airspeed is 100 and you also have 100 knots of headwind, will you move any inch forward?
No, sir.
No. You're moving 100 knots forward, 100 knot wind is coming against you, so which means the aircraft is going to stay up in the air like a helicopter. It is still having lift because the air is blowing over the wing. You cannot say that it's not flying, it is still in the air, but it's not going to move. Right? Therefore, what is happening to the range here?
Range is 0.
Now, if I want some range, what am I supposed to do? That's what we told yesterday, told before, previous class. In the headwind, if I want to increase my range, I have to fly faster. When I fly faster, now I have net 20 knots in that direction, so 1 hour I'll at least travel 20 nautical miles. Otherwise you won't travel anything, right? Your range will be 0. Now we are not really concerned about range here, we're looking about endurance here. What about your endurance of 2 hours? How is that going to change with 100 knots of headwind? So think about endurance, it is just the time that you would stay in the air, is 2 hours. And you have 100 knots of headwind now. So how is that endurance going to vary? Is it going to increase? Are you going to get more endurance? Are you going to stay more like 2 hours and 30 minutes in the air? Or are you going to stay less like 1 hour 30 minutes in the air?
No, sir, but you will stay at the same time in the air, right?
That's
Whether
it.
it is wind or not.
Correct. It doesn't really depend upon the wind, because endurance is talking about the fuel that you have, and that's conversion to time. So as long as you don't drain out the fuel or add fuel to your wings, endurance is sealed. It doesn't really matter what your wind is. You are going to stay up here, whether or not you're moving. You're going to stay up for 2 hours, and once the fuel is over, it'll come down. You might have traveled some range, might not have. It's least bother. But the wind does not have an influence on endurance. Does it make sense? It simply makes you stay up in the air for 2 hours. Doesn't matter you travel east, west, north, south. You haven't traveled. It does not change. Once the fuel is over, you'll come down. So the headwind is actually a tailwind, or on that matter, any given wind is having no effect on the endurance. Make sense? But that is not the case with the range. If you have headwind, the range reduces, and if you want to increase your reduce the effect of headwind, you have to fly faster. If it is a tailwind, that is going to increase the range, and to maximize the effect of tailwind, you have to fly slower. But in case of endurance, wind has no effect. Is that clear? The third one is altitude, which affects the endurance, right? So again, depending upon the type of engine, the altitude actually varies. Some aircrafts have very good endurance, very close to tropopause. Some will have endurance very close to around 10,000, 15,000 feet. You see why turboprops and stuffs, the ATRs, and they fly at lower altitudes because of that. The disadvantages, they have to now face all the weather, because weather is all closer to the earth. And some aircrafts are more efficient, fuel efficient, when they are at sea level, like your propeller driven aircrafts, your the Cessna, etc. are all efficient when they are at sea level. That is how it is built. which means any takeoff and any climb out is going to reduce the fuel efficiency. So depending upon the type of engine, the altitude at which you get the minimum power consumption or maximum endurance will vary, right? All right, let's look at this question number 154. Yes, Anuj. To achieve maximum range. You can correct that. It's not maximum range. You can cut that and write it's maximum endurance. To achieve max endurance, an aircraft must be flown at a speed that produces
minimum power.
Yeah, maximum endurance is minimum power. Charlie is the answer, right? What about minimum drag? What is that going to give?
Maximum endurance.
It's going to maximum range. Minimum drag is max max endurance, correct? Max range, correct? All right, now 155. Yes, Dipanshu, try the question. Which of the following statements are the factors?
Delta, sir? Please
That is not connected to power. That's connected to range or minimum drag. So the lift bar drag ratio is not going to be the best. Is the drag minimum for maximum endurance? For maximum endurance, what is minimum?
Maximum endurance. Minimum power.
Power is minimum, not the drag, right? So if you look at the curve here, you can see this is a curve for power required. Minimum power corresponding to minimum power speed. This is what corresponds to max endurance. Well, how can you find out minimum drag from this? As he told before, minimum drag. That's right, tangent. So you can see minimum drag is actually at a higher indicator speed than minimum power, right? Therefore, you can see the speed at which minimum drag happens is actually more than the speed at which minimum power happens. Correct? Which means if I fly the aircraft at minimum drag, what is going to happen to the power? The power consumption is actually higher.
You have to increase your power.
So basically, when you are flying at minimum drag speed, your power consumption is actually higher. Because power is lower, not at VMP, it's at VMD. So not at VMD, it's with VMP. Therefore, when I fly at minimum drag speed, the power consumption is actually higher. Anywhere on either side of this minimum power speed, the power is going to be higher, right? And therefore, it is not going to give you max endurance. So minimum drag is not going to give you max endurance, and therefore, minimum power speed is not going to give you max endurance, and for that reason, your lift bar drag ratio is not going to be the best. Did you understand? In this graph, where is lift bar drag ratio best? At VMD or VMP?
I think VMP.
VMP?
No, VMD.
Minimum drag, sir.
Basically,
Yeah, minimum drag speed, which is right here, right?
maximum lift is
Right?
minimum drag.
That's right. So this is where we have lift bar drag ratio best, right? Sorry. Yeah. So what happens if I fly at VMP, minimum power speed? What happens to my drag there? My power is minimum, but what about drag? Any other speed other than VMD,
Drag is more.
drag is going to be higher. You cannot see that in this diagram because this diagram is not depicting drag curve, it's power curve, right? So if I draw the drag curve is actually going to go higher like this. So at a speed other than VMD, the drag is higher, and since the drag is higher, will the lift bar drag ratio be best here? No, because the drag is not minimum, power is minimum there, right? And power is drag multiplied with task, that is different. Minimum drag is not minimum power, right? Therefore, that is where drag D is not the answer. Yes, Dipanshu, which of the following statements on factors affecting endurance in a straight and level flight is not correct?
Headwind will decrease and the tailwind will increase the maximum endurance.
Yeah.
No, endurance cannot depend on the.
That's
This is
it.
the answer, right?
So that is the answer. Endurance is not dependent on wind. It doesn't matter what the wind is, nil wind or not, any given wind, it's independent. Therefore, that is the answer. But let's look at the other options. Yes.
Yes, sir. Higher the weight, lower the maximum endurance. Correct. More the weight, lower will be your endurance.
That's right. Why? Because higher the weight, higher the lift required. So you have to fly at a higher speed,
Yes.
and higher speed is going to produce more power.
Yeah.
right? Therefore,
It is correct, sir, right?
that's correct, yes. Because the minimum power required is going to be higher at a higher speed. Right? You can write a note there under Bravo. High minimum power required. High minimum power required. Anywhere left, right of minimum power speed if you fly, the power is going to increase. Anywhere left, right of minimum drag speed you fly, the drag is going to increase. High minimum power required. Alright, next one.
For piston engine aircraft, best endurance is achieved when flown at a when flown at as low as possible with the engine RPM as low as possible. Yes, this is also correct, right? Because piston engine, turbo jet engine has to fly lower, right?
No. This is question number 155, Charlie.
Oh, sorry. I was reading one. Yeah, sorry. Piston engines achieve the best endurance at lower altitude with a minimum RPM below.
You see, what is the, you're talking about minimum endurance, and that can be connected to minimum power required. What's the equation for power? Power is equal to drag into TAS. Right? Power is equal to force into velocity. The force you're looking at is drag, velocity is true at speed. What happens at lower altitudes? What is the TAS required at lower altitudes? For a given indicated airspeed, the TAS required at lower altitudes because of higher density is going to be lower.
Low.
As you go up, since the density is reducing, you have to compensate it by increasing the TAS. Right? What happens when TAS reduces to the power required, minimum power required?
Reduce.
And therefore, what happens to endurance? When power required reduces, endurance increases. When it comes to piston engine aircraft, flying at sea level, that's the lowest it can fly, is going to give you its best endurance. Unfortunately, aircrafts are not meant to be or fly at sea levels. You have to climb and go up, and therefore for piston engine aircraft you have to kind of accept that lower fuel efficiency as you go up. Do you understand this? Why is endurance more at lower altitudes? Lower altitudes, TAS is actually lesser, and therefore the minimum power required is less and endurance is more. Right? We can write one line.